We have a case of balance bar, and this balance bar has 2 point loads or forces acting on it, and force 1 or P1 is equal to 30 kilonewton and force 2 is 30 kilonewton, as you see, and the balance point is C. The distance is equal from both sides, 10 meters, 10 meters. So neither forces or loads are able to cause any rotation about reference point or point C. Let's take another scenario or case. So let's try this case. In this case, what we did is we changed the value of P2. We reduced the value from 30 kilonewton to 15 kilonewton, and what happened is that there is a rotation caused by P1, and this rotation is counterclockwise. So if we would like to bring this balance bar to balance status, I'm pretty sure you will say just change P2 to 30 and we are good. That is true, but now what we have noticed in this case is that the change in the force will change the status of rotation. Let's try another case in which we'll be using not only the force, we'll be using something else. If you look at the case now here, we brought this balance bar to balance again from the unbalanced case by changing the distance. We changed the distance from 10 meters to 5 meters. So now this bar is again balanced about point C. So as a conclusion, we understand when we change the force, the rotation changed. When we changed the distance, the rotation also changed. So what does that mean? The rotation is defined by two elements, the force element and the distance element. These are the two, and distances to mention here is perpendicular distance. Now, having said so, now we would like to talk more of a mathematical format. So having this rotation, as we had before in the forces, we have the forces that go towards east is positive, and the forces that go upwards are positive. Same thing goes for rotation. In rotation we have a naming convention, and for clockwise rotation is negative and counterclockwise rotation is positive. So now if we would like to analyze these mathematically and calculate the amount of rotation, because now we know there is rotation, but now if we would like to go and calculate the amount of rotation, then we will have these two elements, force and distance, and we'll exercise this rotation calculation. So let's start with the first case, the case of at the beginning here. So there's a rotation in this direction. This will cause a rotation in this direction, and this, as we said, is positive because it's counterclockwise, and this will cause rotation in this direction. This is a clockwise and it is negative. We are talking about rotation about point C. So as we have defined the rotation, let's call this rotation M1 and this rotation M2. So M1 is defined by force multiplied by distance. Let's change color, I guess. So how much is M1? And of course M1 is positive, so plus, and the force is equal to 30 kilonewton, and we'll keep the units so that we'll know what are the units of the rotation or moment. And how much is the distance? The distance is 10 meters. So what do we get for M1? We get for M1 300, and that is, the units are kilonewton dot meter, and it is positive. Now let's see what is M2. Now M2 is equal to, because it is negative, so put negative. And how much is the force? The force is again 30 kilonewton. And how much is the distance to point C? This is the rotation point or point of rotation, is equal to 10 meters. So how much is the M2 is equal to minus 300 kilonewton dot meter. Now to mathematically calculate the amount of rotation, the sum of all rotation about point C. So the sum of all rotation or moments about point C is equal to how much? This is the question. So to solve this question, we say it is equal to the sum of all rotation. The sum of rotation, we have one rotation which is plus m1, and the other rotation is minus m2, is equal to the sum of all rotation about C. So let's proceed with this. So the sum of all rotation is equal to plus m1 is equal to plus 300, and m2 is minus 300, and the answer is equal to, so the sum of rotations above C is equal to 0, and that is what we have, because we say that there is no rotation. So we mathematically have proven that there is no rotation on this, for this bar. Now let's go and take the other case in which let's first of all, so for this case, what we have again is we'll go with the same procedure. So again, we do let's do an immediate sum of moments about point C is equal to how much? We have m1 plus m2. That is the sum of all rotations about C. m1 is equal to, again this is positive, but it's counterclockwise, 30 kilonewton, multiply the distance is equal to 10 meters, so we get plus 300 kilonewton meter. That is m1. Now m2 is equal to, again the force is 15, this is negative, 15 kilonewton multiplied by 10 meters, so the answer is minus 150 kilonewton meter. Now if we sum all moments about C, we'll have m1 plus m2, and that is m1 is equal to plus 300 kilonewton meter plus m2 is equal to minus 150 kilonewton meter. So the sum of moments about C will be equal to plus 150 kilonewton meter, because it is positive, so that means the rotation, we are rotating in this direction, and that is what is happening. So that is for case number 2. So we've proven mathematically that there is a rotation, and this rotation is counterclockwise because the answer is positive. So now let's explore the third case. So if we will the third case, again very same procedure, we do the sum. For the third case, we say the sum of moments about C is equal to how much? And we have m1 is equal to, again, force multiplied by distance, and that is force is equal to 330 kilonewton, and distance is equal to 5 meters, and of course this is positive, so is equal to plus 150, that is kilonewton meter. Now m2 is equal to same thing, force multiplied, but this is negative because this is rotating clockwise, and this is counterclockwise. So minus force is 150 kilonewton, and distance is equal to 10 meters. So you get minus 150 kilonewton meter. Now what is the sum of moments above C? Is equal to m1 plus m2, and m1 is equal to plus 150 kilonewton meters plus m2 is equal to minus 150 kilonewton meter. So the answer, the sum of all moments above C is equal to 0, and that is what we have here. There is no rotation. There is no rotation. So that is the answer.